I'm Philippe. I work for Livestorm as a video streaming software engineer. Livestorm is doing video conferencing software, web-based. So we are heavy users of WebRTC. And today I wanted to present a tool that we've been developing for quite a few months and have been using on a day-to-day basis, I would say, to actually measure the quality and instantly measure the quality of the audio and video streams our users would put to the network. So we are users of WebRTC, heavy users of WebRTC, and I would like to take a few words to explain how we use WebRTC actually. How it is implemented in Livestorm. Well, we actually have nothing, almost nothing, at least nothing in the back end. We use the Vonage SDK, as Erin mentioned, we also use that. So we don't have any infrastructure by using that SDK, that's one advantage. How it works, it's like, you just integrate their JavaScript SDK within your application. You use it to publish and subscribe to audio and video streams. And then you send that to their infrastructure, which is actually composed of SFU servers. So everything for Livestorm stays in the front end. Now, we are dealing with video conferencing, and often we have quite of the same questions that keep coming, recurring questions like, can you hear me? Do you see my screen? Or do you see me well? Obviously, usually when you have a video conferencing system, what you have is that you have your own image that is mirrored to you. So this is not the same image that others will see, other participants will see. And it's often at the best quality. It is at the best quality possible. So these are mainly the two differences. It will be mirrored, and also it will not be at the best quality for the remote participants. Why? Because obviously there is the network in between. So the network can be bad on the publisher side. That's one thing, and it can also be bad on each of the participant side, obviously. So I would say there is kind of not a lie, but it's something that we would say with this acronym: video isn't what you see, is what you get. Now we have some tools in WebRTC in the browsers to measure the quality. They are built in, they are very useful. If you open a tab with the Chrome WebRTC internals, you will see a bunch of statistics regarding the RTT, the packet loss, the bitrate at which you're sending. You have the equivalent in Firefox with about WebRTC. And there is also the GetStats API that you can use to develop your own application to measure the quality of your video streams. So this is what we did. We decided to write a Chrome extension that would be useful for us, but also to see how other tools were performing when doing video conferencing. So it gives the user an instant view, a very easy view of the publisher statistics. We don't care about all the incoming video streams, we just care about what we are sending to the network, because this is where we can't really see what's happening. So here, for instance, you have a bunch of statistics like which device you're using to transmit the audio and the video, which codec you use, and also the packet loss, the round trip tap, and the bitrate. Now, in a typical Livestorm session, this is what you would have. You would have one or more participants, and you will have the view of the Chrome extension on the left, saying that you're using that device to transmit your audio. And one interesting thing that you can see also at the end is the different resolutions that you send to the network. So this is an important feature of WebRTC, which is called simulcast. It's the ability to send different types of quality to the network. Why is that interesting? Well, because you don't necessarily have on the remote participants a good network connection. So depending on the quality of the connection on the remote participants, they will subscribe to the small resolution if they have a bad quality, or to the good one if their connection allows it. So this is nice, but when you have many users in a web conference, what will happen is that everybody would send all the 3 video layers that you saw earlier, and we have, as a web application, video conferencing application, a layout, meaning a distribution of the video tiles that is not static. We have people who maximize their streams, so we can see them in a large view, and you have only one stream that can be maximized. The others would be minimized then. So it doesn't really make sense in that case to have all those video qualities being sent. And because of that, we also had users complaining of a high bandwidth usage sometimes, and sometimes CPU as well. So we decided to dig into this and see if, with our layout that is dynamic, we could improve the user experience for our users in Livestorm. So we have found very interesting resources in the WebRTC community. The first one being WebRTC hacks, and actually we found some ways to dynamically switch off and on the simulcast layers that we would send over the network. And it turns out to be also usable with the Vonage SDK that we use. So that was interesting. So we documented ourselves, we looked around, we saw that daily.co also had a very good article, and we started building with that. So here is the result of what the modifications that we made in our code. We decided then to, okay, when I'm transmitting over the network and I am minimized, okay, there's no need for me to transmit all the simulcast layer, I will just send the smallest one. So here you can see that I would just say, send this small resolution here, which is adapted to the size actually of the video tile. But the maximized stream itself will be received and sent by the publisher at full size. Also, one interesting thing is that these Chrome extensions helped us detect new features and sometimes even bugs. There was something new that we actually saw with the Chrome application. It was something called, that Vonage called AMR, Adaptive Media Routing. The idea behind that is that if you have 2 people in a video conference, then you would send your stream directly to the other participant without going to the SFU. And if you had 3 or more participants, then it will switch to the SFU mode. And yes, we detected a bug with that regarding the audio. I will explain that just after. So this is how we discovered this new feature, this new AMR feature, Adaptive Media Routing feature. We were doing regular call with our application, and here after that we switched to the Vonage Playground to make sure that we had the same results. Actually, what we saw was kind of different that we were used to see in the past. We would see that we would actually have 2 peer connections connected when we were only 2 people in the same video conference. And we asked ourselves, okay, that's not really normal. I'm sending my audio streams to 2 different people. Which is the other people, actually? So we asked Vonage about that. They said, okay, that's a new feature. They explained to us what was AMR. We said, okay, so then why is that I have to send my audio stream to an external endpoint that I don't know about? It is actually a connection that is made to the SFU when you start a connection between two peers. So you have one part that is peer-to-peer, and another part which is audio with silent traffic, actually, that connects to the SFU. This is needed for them to easily switch to the SFU mode when you have another participant that comes in, so that you don't have any interruption on the traffic. So that was great. We had a good explanation of what AMR was, but at the same time, we figured out that there was an issue here. Why? When we are in this call with two persons, it turned out that if you switched your microphone to another device, then the connection to the SFU wouldn't switch as well. So when you have a third person that would come into the call, you would stick with the other microphone. Which happens is that for two people, you could hear the person that you were talking to, but with three people, you wouldn't hear anything. So that was an interesting case of seeing how there was a bug that was introduced into that, and the Chrome extension here helped us a bit. Here you can see that the microphone didn't switch when we were adding a new person to the video conference. So we keep developing this extension, although not every day, because it's a very small code. There is not much code, and it's quite easy to use. And but there are things to improve. Obviously, if we find bugs, we try to catch up with it. And also one thing that can be interesting is to include what we call temporal simulcast, which is different from the natural simulcast that we know that consists in transmitting different resolutions to the network. Temporal simulcast is mostly used in when you use screen sharing and you cannot modify or scale down the resolution. Then in that case, you would send the same resolution, but at different frame rates. So that would be two streams of the same resolution at the different frame rates. This is something that is not easy to display in the Chrome extension that I showed, but maybe we'll do it in the future. So that's it for me. And if you have any questions, I'll be happy to answer them.